Have you ever thought about using the same tools and procedures like software developers as a data scientist? Then this is exactly the right video for you to introduce you to DevOps for machine learning. Hi, I'm Sascha. Welcome to the third video of the 5-video series about DevOps for machine learning. If you are new to this channel and want to learn more about advanced analytics, machine learning and cloud computing, start now by subscribing to this channel and click the bell icon so you don't miss anything. In the first 2 videos, we saw how to set up Azure DevOps, deploy our code, our Python code in there, and use the toolset of Azure DevOps for checking the data quality. In the second video, we saw how to connect Azure Machine Learning Services and Azure DevOps to work together. And in this video, we are going to see how to train and register our model. And we are back in Azure DevOps. So let's review what we did so far. Let's go to the pipelines, look at the pipeline. So we first did some local tests on the build server, set everything up. Then we connected and created the relevant Azure Machine Learning Service resources. And the next thing we want to do is adding tasks to train, register, later download the model. Downloading for one reason, I want to add the downloaded model as an asset to the outcome of this pipeline, just as an additional task. And those Azure CLI commands are more or less standalone. And to create kind of a session between those separate commands, I'm going to use JSON files, which could be created by each of those commands as output and can be used as input parameters into the next command to more or less create a chain of commands. And to be able to do that, I want to create some folders on the build agent. Therefore, I create a bash command, use an inline function and create 2 directories, one which is called metadata and one where I want to store the models locally while downloading that somewhere. So I call that models. Give that thing a name, create metadata. And models folders. And now we can continue with really training the model. Therefore, I'm again using the Azure CLI command. And in this case, I want to execute or train the model. To be able to do that, let's switch to this command, pick again my connection and my inline script and add that script. What I want to do is run or submit a run in this system. I have to specify again the resource group and the workspace where this whole thing will happen. I have to specify a name for the experiment, which I'm going to add to the variables soon. Then the name of the cluster, which will be the compute target, so where should that run. Then again, this system, it's an external system, it's my Azure Machine Learning Compute, and in this Azure Machine Learning Compute cluster on each of these nodes, the system will create a Docker image. And then out of the Docker image, provision a Docker container, and in that Docker container, run that training as kind of a sandbox. And the base image is a Docker container or a Docker image which has Anaconda already installed. And therefore I couldn't specify to define that virtual environment in that Anaconda environment a conda dependency file. I added that already to the source code. So my conda_dependency.yaml file contains all the necessary relevant information how that training environment should look like. Then I specify the Python file which is the initial Python file to be executed. I said I want to use JSON files to transfer information from this command to the next one. Therefore, I add this parameter to create an output file called run JSON, add that to the metadata environment to really export those values which are generated out of this run into that run JSON. That's more or less the training part. So I call that train model. After the model has been trained, in my run, in my experiment, it contains the relevant pickle file which is generated out of this Python code. But before I move into that space, let me first define the variable for my experiment name and call that diabetes scikit-learn to really have that name specified. Since I'm here in that area anyway, I want to, of course, also register the model into my model versioning environment. Therefore, I have to specify a name or a unique name for that model. Again, I set a variable for that called diabetes model. Going back, so that task should work now. And I want to add a few other tasks. One, of course, for registering the model in the model registry. So I have that as a versioned model, which I can track, see what's happening in there, see where the model will be used, in which APIs and so on. And again, to be able to do that, I'm using a command, going in there, specifying the subscription and an inline script. And again, so I want, going to the model management section, want to register a model. I have to specify again the resource group and the workspace name, the name of the model out of that variables. As an input parameter, I use the output of my train model run. So I get the run model in there. I need to specify the path out of that run where I stored the model file. In this case, it's in my run in the outputs directory, in the models directory as a pickle file. I can specify a description of that model. I can also add tags like, for example, that the data is diabetes, that this is a regression model, and that I use the model framework scikit-learn for that, and output the results of this command again in a JSON file. In this case, I call it model.json to use that later on. That would be it, theoretically, but I decided I want to have a little bit more values in there, but for that, just a model. So a bit more value of my DevOps environment. For example, also add those things, or the output, in this case my model, into my pipeline as an asset. So I can copy that in there and, for example, say that I want to download my model, just to be able to save that as an example. Again, use an inline script and my connection, and in this case I'm calling the download model command. I have to specify again the resource group and the workspace, and in this case I'm as an input parameter I pick the exact model ID, which is a versioned model ID out of that JSON file. I want to store that into the models directory, which I created up here in my bash command, and if the file already exists I want to override that. So that's more or less this command, pulling the file down here. And up next I want to register and deploy all those artifacts into the relevant space. For that I need to mess a little bit with the settings, but I want to copy all those files into one directory, pick the relevant file. I can also either select it, but in my case, I want to use variables. So in this case, my build source, I can specify several directories. I want to specify 4 directories in that case. That would be the metadata and the models directory, which we are generating while training and downloading the model, as well as the deployment and the integration tests directory, which I'm going to use in the release pipeline. I also have to specify the target folder, which will be in that case the artifact staging directory. And last but not least, after I copied everything into the right place, I want to publish my build artifacts. So going in there, and I have to specify which directory to upload. I copied those already to this directory. So let me just specify that this is the staging directory of my build artifacts. I have to give that artifact space or that artifact a name. I just call it drop, where all the relevant information will be, more or less published. That's fine. Looks good so far. And just use this one. So let me save everything and execute the whole pipeline to train the model, register the model, download the model locally, copy everything together into an artifact and use that one for later usage and publish that as part of my pipeline artifacts. And again, I'm going to pause that video and resume as soon as the job is done. And the job completed after around about 17.5 minutes. 100% passed, that looks good. So let's have a look, especially at those tasks which we changed. Of course, most of the time went into training the model. And it's not only training the model. If you have a deeper look into that task, what it first does, it generates a Docker image. The Docker image is only generated once, and if you use the same dependencies like you did before and don't force it, it's not regenerating that image, but reusing the existing one to create a container. So that's what it's more or less doing, using Anaconda to install the dependencies, as well as pip with the non-Anaconda dependencies. And in the end, after completing everything, it's pushing that to the container registry, which means if we now have a look at the resource group, there's an additional service added. In our case, the actual container registry. So that's been added. This one is a different test, so just ignore that. And after it's been pushed, now the ML compute service has been asked to do its thing, and it's really executing the script, and that's the streamed protocol out of the internals of that Docker container. I'm going to dig into what's happening exactly in here in a minute. After that, the model will be registered, and it's sending me the ID back that the diabetes_model has been registered in version 1. Then we are going to, and then the next task is downloading that model to the local drive of the build server, copying all the relevant files, so 10 files into the target folder, 5 for the deployment, 2 metadata files, which we generated while training the model, the downloaded model in the models directory, as well as the 2 files for the integration tests, which we are going to use in the next video. And last but not least, it's saving those 10 files as an artifact. In terms of artifacts, you see that one artifact has been published. And if I go into that, open that drop artifact, I see exactly the folder structure with the deployment, the metadata files, the model, as well as the tests. So that has been completely published as the outcome of that pipeline. What I also want to show you is what really happened in the source code, in the training script. So let's have a look at the training folder. First of all, a conda environment file, which gives the environment a name, which defines which Python version to use, some default things to be able to use the Azure ML service, and once again, the packages scikit-learn, joblib, numpy, pandas, matplotlib for creating graphs, and seaborn if I want to use those as a environment of that for that image, for the Docker image that will be generated and used for the training. Then the training file itself, which is of course just importing some stuff. The interesting part is really an object for the run as well as for the model. Then I get the context where this script will be executed, so more or less a reference to the run where this is executed. Then I'll load from the workspace blob store the files which are uploaded, display some things. Yeah, this is just a demo script and more or less executing a rich or generating a rich model. And in the end, test that model, show the mean square error of the generated model, store that model in the model folder as a pickle file, and in the end upload that pickle file to the run so that it's available later on, and then mark the run as completed. One thing is missing: where does this reference come from and other things, and therefore I added a run config in here, which is defining that the run is a Python script in the end, or it could also be a PySpark and later on R and other things. So the framework is Python. In my case, prepare the environment, so generate a Docker image if this doesn't exist anymore. So for the first time, it will generate a Docker image for me. Then I can again, from the outside, specify where's the conda file, which base Docker image should be used to generate that. So I could either use my own base images or give it a Docker file. Same for GPU support. I made it false, so I don't need, this package is not meant to run on GPUs. Some basic things like 1 GB of RAM and so on, so basic stuff. As well as my data reference, which means that I specify that I want to use the blob store, that my subfolder is diabetes, and want to download the files to the Docker container and run it locally. Other option would be mounting. If files already exist, please override them. So that's more or less my reference. Last but not least, let's have a look what happened in the workspace. So in the experiment section, now I've got the experiment. I see that I run that 2 times. The first thing I made an error, so it failed. But anyway, that's the second run. And I did some logging in the script. This is displayed here, so some values to show you that it's able to log, say for alpha and MSE. And if I want to go back and look into the training script, that's what I'm using here. Log the alpha value, log the graph, so it's the graph which will be displayed, log the mean square error, and of course upload the files. And those files are in the output section in the models directory. Here's my pickle file. I can download it directly if I want to, but I'm going to use, I did that already and added that to the artifacts of the job. Yeah, to give you a brief idea what it's doing in the end. And as you can see that this contains a registered model, and I also have a link to that registered model which came out of this job.
So now we completed the 4 steps to train the model, to register the model, to download the model and save it as an asset in our Azure DevOps pipeline. In the next video, we are creating our first API and deploy it to a production environment. For that, we use Azure Container Instances. I'm also very interested in what you think of this series, of the first 3 parts. So please do me a favor and use the comment section below and tell me what you think. I'm also interested in what else I could share on this channel. So hey, feel free. ask questions, make suggestions about topics. I'm looking forward to read from you. So see you soon.